Hello students, this is Sulagna ma'am. I teach philosophy at Janki Devi Memorial College. Today we'll be covering a very important section from Truth Functional Logic paper. This is the paper which we offered to the 4th semester students of philosophy honors. And today we'll be looking at how truth tables can be used as a decision procedure. Alright, so to begin with, we are going to look at how to construct a truth table. So as we all know that a table comprises of two different aspects, okay? So out of which one is the rows and columns. It's going to have certain number of rows and certain number of columns, okay? Say for example, we prepare a table for P dot Q. And so as we all know already that in a function, just a quick recap, in a function there are two different sets of things. One is variable, the other is a constant, okay? So variable are P and Q, so we have two variables here, P, Q, and a constant which is dot, which is a conjunction, which has been covered previously. And it's the literal English translation of dot is and, okay? And can be understood as the English translation for dot, which is the conjunction. And this is a conjunctive truth functional form, okay? So this is a function. And for example, in case of a function, as we all know, that y function is equal to 2x plus 1. So this is something, just a quick recap of what we have covered previously. So y function is 2x plus 1. Here x is the variable, alright, and depending on the value of the variable, the value of y gets decided. For example, if the value of x is 1, say for example x is equal to 1, so it's going to be, y is going to be 2 into 1 plus 1, so it's going to be 3, okay? So this is how it works. Now coming to the next point, that so this is the general understanding of a function. We are looking at a truth function, which is P dot Q. It's a conjunctive function where P and Q are variables and dot is the conjunction, the major connector, the connector between the two variables, P and Q. And this is the example of the function as a whole. Coming back to the point that we are trying to draw a truth table for P dot Q. Okay. A table has two aspects, like I said, which are rows and columns. So here, how many variables do we have? 2. So here, the number of variable is 2. There's a rule for this to determine the number of rows here. So it's going to be 2 to the power n. And here, since n is 2, so it's going to be 4. Okay. So here we have 1, 2, 3 and 4. 4 rows in this particular truth table for P dot Q. So we'll start from the left and then we slowly move towards the right. And we'll start with the first variable P. Okay, the leftmost column is going to be for P. Then the second one, the second leftmost is going to be for Q. And the rightmost, which is the main column, will represent the function as a whole, which is P dot Q. Okay. Now, coming back to the next point, that how do I know that how many rows this is going to have? So here we have the formula for number of rows. It is 4 here, okay? And number of column, depending on what are the parts of the respective function. For example, here for P dot Q, we just have two parts, P and Q, and the main column representing the conjunctive function, P dot Q, which is the rightmost column. Alright, is it clear to everyone? Alright, now let's try to build up the truth table. Now, the truth table as a whole is going to contain truth values. Truth values meaning we all know that it's either true or false. These are the two truth values. T represents true, F represents false. And from the leftmost column, the 50% of the rows will be filled up with T. The rest 50% will be filled up with F. So this is how it looks like. T, T, F, F. Okay? Do you understand this, everyone? Okay, some of the students sometimes have a little bit of a confusion about what is a row and what is a column. Rows are these. These are horizontal. Okay? Columns are vertical. These are the columns. And these are the rows. Rows are what? Rows are horizontal by nature. And the columns are vertical. Alright? Okay, now let's move on to the second column, which is the second one for Q. For Q, now the rule is, again just repeating, we're going to move from the left towards the right. And in the second one, in the second column, we will be having 50% of the number of T's and F's which was there filled in the first column. In the first column, we had T, T, F, F. So now we're going to be having T, F, T, F. So that's a pattern which we are going to get to ourselves, and we repeat that pattern. Here we just need to repeat it twice. So we're going to write it as T, F and T, F. Okay? And so this is how the truth table looks like right now. Then we move on to the final column, which is the P dot Q column. This one, P dot Q. So here I'm going to prepare the, fill in the truth values for P dot Q. Okay, so now let's again quickly recapitulate the rule for conjunctive function, P dot Q. What was the rule for conjunction, girls? So here what we have been understanding so far, that for each function there is one particular rule. For conjunctive function there is one rule. What is that one rule? That as per the rule, both the conjuncts P and Q, if they are true at the same time, then P dot Q is going to be true. This is that one rule for conjunctive function. Okay, so here now let's check in which of the rows both the values of the conjuncts P and Q are simultaneously true. So that's happening in the first row and nowhere else. So in the rest of the places it's going to be false, and only in the first row, as we can see, it is all true. Okay. So this is how the truth table for P dot Q truth function looks like. Now the next question which arises in our mind is, why are we doing this exercise? So this is a very common query which comes to the mind of a student. Now, what do I get by doing this? So the idea is, like I said, we are learning decision procedures, and truth table is a tool which is helping us to decide. Right now we are focusing on the nature of a given truth function. Okay, so for example, here the truth function which was given to us is P dot Q. And if somebody asks that what is the nature of P dot Q? So here if we look at the main column, like I said that this is the main column, the rightmost column is the main column here. So if we see, it's a mixture of both T and F. And as we learnt in the previous chapter, that a mixture of T and F is known as contingent, right? So here now we know that a given truth function P dot Q is a contingent truth function. It's contingent by nature. Right? Is it clear to everyone? Now let's have a look at some other type. At the second type we'll be looking at. Okay. So let's have a look at negation P. Okay, so for example, negation P, which is a negative function which has been given to us, and someone asks you to prepare a truth table for negation P in order to determine the nature of the function negation P. Alright, again the same way we're going to do here. What is going to be the value of the n? N is the number of Number of variables, how many variables do we have here? It's 1. Sometimes students get confused about it. They feel we have 2 variables, P and negation P. No, the variable is 1. Okay, so the function, while we're trying to represent, we have to break it down into its constituent parts, right? So here the parts are P, and of course negation P is what we're trying to represent. So the number of variable here is going to be 1. So as per the formula, it's 2 to the power n, therefore it is 2. So we have 2 rows in this particular table. Okay. Right. Now let's try to build up this table. So here again the same rule, we have to fill up 50% of the leftmost column with T and F. And of course negation P, we know as per the rule it's going to be the opposite of the truth values which we have in the P column, right? So it's going to be F and T. Again, what is the nature of this particular table, girls? Again, it is a contingent one. Now, let's try something else. Let's try another one which is of a different kind. Let's try P implies Q, wedge P. Okay, again the question is, we begin from the same point, that what is the nature, how many variables do we have in order to find out. That's the first step. So here we have 2 variables, P and Q. And of course the main column is going to be P implies Q, wedge P. Okay, so we have P, Q, P implies Q, and the main column P implies Q, wedge P. So this is the table. And as we see here, there are 2 variables P and Q, so it's 2 to the power 2, so therefore there will be 4 rows. Okay, so 4 rows matlab it's going to be divided 50% T, 50% F, and 50% of that in the second column, TF, TF. Coming to P implication Q, what is the rule for implication, girls? For implication, we know that the antecedent, meaning the part which is there preceding the horseshoe sign, should be true, and the consequent, which is the part which is following the horseshoe sign, should be false. If that happens, then what happens? If P is true and Q is false, then as a whole P implies Q becomes false. This is the basic rule. Alright, following this, we see we get a F only in the second row. The rest of it is true. Okay, girls. Now we move on to the main column, the rightmost column. We had been moving from the left towards the right. Now the main column. So the main column, here we see the next question which comes to the student's mind is, which is the major connector here? Because we see couple of connectors here. Which are the 2 connectors? P implication Q. Implication is one connector, the horseshoe sign, and we see the wedge sign. So let me clarify this, that here the major connector is wedge. So the bracket is really important. Sometimes the students drop the bracket in the process of, in a hurry, or they feel that the bracket is really not important, but the bracket has a very important role to play, because in a way it helps us differentiate between a major and a minor connector. Here the major connector is wedge. Okay. Now let's come to the point that what is the rule for disjunction. For disjunction, we know wedge is a symbol for disjunction. Disjunction in simple English, it's either or. Alright. So for disjunction, what is the rule? For disjunction, both the disjuncts have to be at one in the same time. If they're false at one in the same time, then as a whole the disjunction is going to be false. That is the rule. In rest of the cases, it's true always. Okay. So here, for example, if we're trying to work out, a value for P implies Q wedge P, which are the two columns we are going to focus at? You're going to look at this column, P implies Q, and this. Alright. So here we see that it's not happening anywhere. There are no such instances. There are no such case. We don't find any instance where both the values are false at the same time. Therefore, this entire thing is going to be true. Okay. So what happens then? This entire main column is filled up with true substitution instances. Therefore, the given statement form, which is P implies Q wedge P, what is the nature? The nature is, it's a tautology. Tautology, in English, it literally means what? It means all true. Okay? तो जहाँ पे भी जो मेन कॉलम है उसमें सारे ट्रू सब्स्टिट्यूशन इंस्टेंसेस है, तो वहां पे जो डिसीजन है, जो आपके पास स्टेटमेंट फॉर्म दिया गया है, दैट इज गोइंग टू बी अ टोटोलॉजी. इज इट क्लियर टू एवरीवन? Alright, now let's look at another example. Let's look at another example with the help of which we'll be able to see. So we have now the idea of two types of statement forms, two different nature. One is tautology, where in the main column the truth values are all true. Another we have learnt that's a mixture of both true and false. It is known as contingent. So now we have two things in hand. Now let's see if there's any other way in which we can understand the nature of a given statement form. So let's have another example in hand here. P wedge Q dot negation P dot negation Q. Negation P dot negation Q. So what are the components here? The first question, how many variables do we have? P and Q again. Negation P and negation Q are nothing but the negation of the given variables. Okay. So it's going to be P, going to be Q, negation P, negation Q, P wedge Q, and negation P dot negation Q. Negation P dot negation Q. And the main column, which is P wedge Q dot negation P dot negation Q. Alright students, so now we'll again construct the truth table for the given statement form. This is the main column again, and we move from the left to the right. So it's true, true, false, false, true, false, true, false. Negation P is always the opposite of the truth values which is there in the column below P. So it's going to be false, false, true, true. Negation Q, opposite of what we have in Q. So it's going to be false, true, P wedge Q. What is going to be the value for P wedge Q? The rule for disjunction, what is the rule for disjunction? That both the disjuncts have to be false at one and the same time. Then the disjunction as a whole is going to be false. Okay, so here both are false in the last row. We see they're false, so this is going to be false. That's it, rest of it is true. And for negation P dot negation Q, the rule for conjunction is, for conjunction, both the conjuncts have to be true at one and the same time. Then the conjunction as a whole is going to be true. Okay, so that is the rule. So here we see that's happening in, again, the last row. So rest of the places it is false. Okay. Now let's move on to the main column, which is the main component here, which we need to focus. For this, we look at the two columns where we put a tick mark here. These two we are going to focus upon. Again, the question comes, which is the major connector here? Which is the major connector? All these are connectors. Wedge is a connector, dot is a connector, the second dot is a connector. All these are connectors. But which is the main connector, the major connector? The major connector is dot. Why knowing the major connector is so important? Why is it so important? It is important because on the basis of my knowledge that which is the major connector, I'm going to find out which is the rule I'm going to refer to. Okay. For example, here dot is the major connector. This one is the major connector. Therefore, I'm going to use the rule for conjunction. What is the rule for conjunction? That both the conjuncts have to be true at one and the same time. Then the conjunction as a whole is going to be true. Okay. So here let's now see that where this is happening. It's not happening in any of the instances. See, it's true, false, true, false, true, false, false, true. Therefore, what do I write here? Then I write false in all the 4 rows. So this is the example of a self-contradiction. So this is a self-contradictory statement form. Alright girls, so it's very important to know now. So how many things we know? We know a tautology, we know a contingent, and we know a self-contradictory. Okay, so these are the 1, 2 and 3. These are the 3 types of statement forms which one can find out, which one can determine with the help of what? With the help of a truth table. This is how truth table is helping us to decide, to determine what is the nature of a given statement form. The nature of it is being decided henceforth with the help of a truth table in the form of a technique. Alright, so it's a technique for finding out the nature of a given statement form, and it's extremely important because it saves time, number 1, and number 2, you can do it very easily by using symbols. So there's a lot of precision which is involved. So symbols are used. One of the main reason is it saves it's a very time saving process. Okay, and you can do the same thing by other methods as well. But this is a most easy one. There are various other ways of doing it which we are going to learn in due course, but this is the most basic and the easiest one. Alright, but one needs to be very careful while filling in the T's and F's within the given squares, because you know, once the number of variables are more, for example there are 4 variables, so it's going to be 2 to the power 4 number of rows, which is 16 rows. Therefore, the more the number of variables, the more diverse the table is going to become. Understand? So now we move on to the second bit of the lecture where we use truth table for another very important function. What is the second function which we are going to look at? We are going to use truth table, like I said, for as a decision procedure. So One is we used it for deciding the nature of a given statement form. Is that the only function? No. There's another function. We know that an argument, when it is given to us, then so there's something about it which we can do. When an argument is given to us, one may ask us that what is the nature of the given argument. So what comes to your mind by hearing argument? We know an argument is what? It's a combination of premises. Some certain facts are given to us. That's a starting point. And from those facts, those facts are conjoined by reason. Right? And from there we try to learn something. We try to derive something. We try to reach a conclusion. Right? So that's the way in which it functions. Now, when an argument is given to us, there are two different possibilities. One is it can either be valid or it can be invalid. An argument is either valid or invalid. While on the other hand, what we have just now learned is it's a statement form. And its nature can be three. It can be a tautology, contingent, or self-contradictory. Okay, these three. Whereas an argument can be valid or invalid. Now let's see how the nature of the argument can be determined with the help of a truth table. Okay. P wedge Q, negation P, Q. So here what are these? These two are premises and Q is what? Q is the conclusion. Okay. P wedge Q and negation P are the premises, Q is the conclusion. Now let's try to work this out. So we have P again, Q, P wedge Q, negation P. That's all. How many variables do we have? We have two variables, P and Q. How many variables, girls? Two variables, P and Q. So this is going to be true, true, false, false, true, false, true, false, just like the way we did it previously. 50% filled up by T and F. The second column, 50% of the number of T's and F's which you have in the first column. So it's TF, TF. P wedge Q, how do we decide? P wedge Q, false, false, false ho gaya, and the rest of it is going to be true. Because we see there's only one instance where both the disjuncts are false at one and the same time. Okay, is it understood? Alright, negation P now is going to be the opposite of the truth values for P. So it's false, false, then true, true. Right? Now, after that, what is the next step? So, again coming back to the argument P wedge Q and negation P, what are they? These two are the two premises. And what is the conclusion here? Q is the conclusion. So, here the rule is, if both the premises are true and the conclusion is false at one and the same time, then the argument is going to be invalid. Even in a single instance, even in a single row in the entire argument, representation of the argument, if we find that if there are two premises, both of them are true at one and the same time, and the conclusion, the value is false, then the argument is going to be invalid. So now let's check here. So here, is there any instance? Yes, in the third row, we find that both the premises are true at one and the same time, like this. And the conclusion, what about the conclusion? This is also true. Okay, so what happens then? In that case, this is a valid argument form. Just let me repeat once again. The rule for testing the validity of a given argument form is that you have to see that whether there is an instance where all the premises are true and the conclusion is false. If all the premises are true and the conclusion is false, even in a single row, then the argument is going to be invalid. Else it's going to be valid. For example, here, these are the two premises. This is the conclusion. We see Both P wedge Q and negation P, which are the two premises, they are true here. But the conclusion, it's also true. Okay? So therefore, this argument is valid. Now let's have a look at another example, another little example, which is going to help us understand how does an invalid argument form look like. Negation P implication Q, P therefore Q, P therefore Q. Negation P implication Q, P therefore Q. Alright, so here again let's try to work out the truth table for this particular thing. P P Q, P implication Q, negation P implication Q. That's all we need here. Since there are two variables, thereby we'll have 4 rows again. So let's try to work out the truth table for this. P implication Q, as per the rule, the antecedent has to be true and the consequent false, then the statement is going to be false. That is only happening in the second row. Please note everyone, that's happening only in the second row. Therefore, this is false. Negation P implies Q, what is the value? The value is going to be the opposite of P implies Q. So it's going to be false, true, false, again, false. Right? Now let's see which are the premises, which are the conclusion, which is the conclusion. Negation P implies Q is a premise. P is again a premise. And which is the conclusion? Q is the conclusion. Right? So I'm going to look at the two premises and the conclusion and see whether there is an instance where both the premises are true. Yes, both the premises are true here and here. Both the premises are true and the conclusion is false. Right? So that's exactly what we were looking at. So both the premises are true and the conclusion is false in the second row of this truth table. Right? Therefore, this argument form which has been given to us is invalid argument form. Just one quick note. Please remember that just drawing the truth table and leaving it there is not good enough. One line explanation is very important because you need to clarify the reason why a given argument form is valid or invalid. For example, in this case, this argument form is valid. We have written it's an invalid argument form. But then you have to say that since in the second row we see that both the premises are true and the conclusion is false at one and the same time, therefore the given argument form is invalid. Right? So you must be very clear about it that there can be more than one rows also. Or there can be even just single row where this rule is being followed, that both the premises are true and the conclusion is false. Okay, that is good enough to qualify the argument as invalid. So this is the rule, students, and so just let's quickly summarize what all we have studied today. So we have studied truth table and how to use truth table in the form of a decision procedure. So part 1 of the lecture comprised of number 1, we'll be given a certain statement form. Statement form as in, for example, P dot Q. Okay, and we'll be asked what is the nature of it. So the next question is, how many types of statement forms are there? There are precisely 3 types. A statement form can be a tautology, self-contradictory and contingent. A tautologous truth table, how does it look like? The main column comprises of only T's. T stands for true. Self-contradictory, the main column comprises of only F's. F stands for false. And contingent is a mixture of both T and F. Now, sometimes students ask me that how many T and how many F? There is no such proportion. Even if it is 1 T and all F, it is still a contingent. And even if it is all F and 1 T, it is still a contingent. Okay, is it clear to everyone? And that explanation again is very important. You have to explain one reason that why you call a statement form as a tautology. For example, you will say that this given statement form is a tautology because in the main column, which is the rightmost column, we find all T's, okay, or we find all F's, or we find a mixture of both T's and F's. Okay, clear to everyone? Now let's come to the second part of the lecture where we have been using the truth table as a decision procedure to decide whether a given argument is valid or invalid, right? For that again we learned another rule for this, okay? So here there will be 2 premises given to us and a conclusion, 2 or more, n number of premises, let's say. All the premises have to be true at the same time and the conclusion has to be false and at the same time. Then the argument is going to be invalid. If there are no such instance where the premises are true and the conclusion is false, then the argument is valid. This is the example of an invalid argument form where we see in the second row, we see that both the premises P1 and P2 are true, but the conclusion C is false. Right? Even in one row, if such kind of an instance is there where the premises are true and the conclusion is false and the argument falls apart, it is invalid. Okay? Now again, just a recap about the table. Table in general we know it has rows and columns. In the case of a truth table, which is the tool which we are learning here, it's always important for you to remember how to construct it. The first key rule is that you have to know that the columns are what? The columns are vertical, right? And the rows are horizontal. And the number of rows are determined by the number of variables which are there. And for which I taught you the formula 2 to the power n, where n is the number of variables. For example, here there are 2 variables, therefore it is 2 to the power 2, which is equal to 4 rows. So we have 4 rows here. Okay, and we have to break down the given equation into parts, into its constituent parts, and work out the truth table for each one separately, slowly moving from the left slowly towards the right, and the rightmost column is going to be the main column. Okay, so that's all for today's session on truth table used as a decision procedure. Please feel free to ask more questions to me. I'll be very happy to answer. Thank you, girls.